in this section, we're going to go over how to graph polynomial functions. So look at this first one here. Okay, that's a very complicated function. And obviously, that's not something that we can graph by hand just by looking at it, right? So we are going to use our graphing calculator to do that. However, both to show some work and to get some like specific points on there, we're going to create a table. So let's go ahead and do that. Let's go ahead and put this in the graph into f1 of x. So we're going to have x to the 4, x to the power of 4, minus x cubed, minus 4x squared, plus 1. Right? That's how my function looks. But now, making a table is going to serve another important purpose. So what we're going to do first is create a table for this. Now, you all know how to, get this and move it out of the way, right? Okay. So to pick points, there are a couple of different ways to do it. One is you go to menu and you go to trace, press graph trace. Now, I want to put in these values, okay? So in trace mode, the first one I want is -2, right? Type -2, enter, 9. So I put a 9 here. Without pressing anything else, type -1, enter, I go -1. 0, enter, 1. 1, -3, 2, -7, 3, 19. Okay? Okay, let's go ahead and graph this. At -2, we're at 9. At -1, we're at -1. 0, we're at 1. 1, -3. 2, -7. And okay, I'm not going to graph the -19, but I am going to show how that graph moves up, right? So here, if I go back there, right, let's go ahead and graph this. Right? It kind of looks like that, okay? Okay. So the purpose of this lesson is to now be able to analyze different parts of this equation and graph. So let's go ahead and continue here. Do you see how this function has a couple of places where it crosses the x-axis, right? Now, when we did the table of values, it served a very important purpose of actually helping us graph this precisely, okay? But in addition to that, when I have a table of values, without even, looking at the graph, I can guess where the zeros are going to be, right? Do you see how at each 0, the graph switches from being above the x-axis to below the x-axis? So when the graph is above the x-axis, all of the y values are positive. When the graph is below the x-axis, all of the values are negative. At the 0, the y values switch between positive and negative, right? So if I take a look at my table here, look, I have a positive value. The next one is a negative value, right? That means somewhere between x equals -2 and x equals -1, there is a 0, okay? Where else does that happen? Here it's positive, here it's negative. So somewhere between x equals 0 and 1, there's going to be a 0. And then lastly, here and here. Okay? It goes between negative and positive. This is called the location principle. Okay? So the roots of the function is not an integer value. The x-intercepts here are not x equals negative 2, negative 3. It's like some, decimal, negative 2.4, negative 1.372, right? However, you can estimate them by examining between two integer values, which two integer values there is going to be a sign change in the y, okay? And when you graph on your calculator, you can get a table as well to see this principle. So why don't we go back and same graph. So I showed you one way to get points, right? It was by tracing. Another way is the following. Why don't we all press Control T? Okay? When you do Control T for table, you get a table here, right? And this table also, right, you can use it to your advantage, okay? All right, so here, for the function in example 1, identify between which pairs of integer values the real roots are found. So what did we say? The first one was between negative 2 and negative 1. So I say between negative 2 and negative 1. Between 0 and 1. Between 2 and 3. Okay? All right. Okay. Last, yep.
Isn't there 4?
Oh, you're right. We missed one. Where did we miss one? Right here. Right? Between negative 1 and 0. Good. Thank you. Between negative 1 and 0. Thanks, Ethan. Okay. All right. The next thing we're going to talk about is a relative maximum or a relative minimum. Yes? No. And you could like abbreviate between as like BET dot. Like, I don't care. Okay. So relative maximum and relative minimum are maximum and minimum points that are found within a specific region, not necessarily over the whole function. If you look at this function here, if I were to ask you what is the maximum value of this function, well, you can't tell me because this goes up forever and ever and ever, right? But if I were to tell you just within this region in between the red, what is the maximum value? That's that point A, correct? Okay, so that's what we're talking about. That's what a relative maximum is. Okay, so a relative maximum looks like a peak on a mountain, and it happens when the graph, changes from going up to going down. Okay, so that right there is a relative maximum. And this right here is a relative minimum. It looks like a valley. Okay? Questions? Okay, so when we talk about maximum or minimum, we only give the x values. So why don't we go ahead and take care of that now? Back in the same example, for example 1, so if you cleared your calculator, take a minute and go ahead and plug this function back. If you have a table here, to get rid of it, you can do Control T. All right, and I'm just gonna go for good measure, menu. Let's everybody do this. Menu, window zoom. Number 5 is standard zoom. So why don't everybody go ahead and do that and bring it back to the standard window. Values, right? So let's take a look here. we have a minimum value right here at the peak, at the value, right? To the right. Okay, so here's what you're going to do. You're going to go to menu, analyze graph. So to find that minimum, which one of these are we going to choose? Minimum, number 2. Okay, you're going to get this, drag it to the left of that specific point, click the center button and let go, drag it past, click the center button and let it go. And here, that's the location of the minimum, okay? We only look at the x values. So here we're going to say there is a relative minimum for b at x equals, what was it? 1.84? 1.84. Okay? Now, are there any other minimums or minima? Yeah, all the way to the left. So we do the same process all over again. Menu, analyze graph, minimum, here, and here. So it's x equals negative 1.09. All right, here, relative maximum, menu, analyze graph. Now I want to find the maximum. Don't switch these out, like the calculator might glitch on you. So here, it's at 0, 1. So what do I put? X equals 0. Okay? So the good thing about the TI Inspire is it's very much menu based, like the word processors and like everything else that we use. So whatever you need to find, whether it's a 0 or whatever, you're always going to go into menu, analyze graph, and that's where the majority of the things you're going to find are. Okay? All right. So let's take a look at this one. So now it says use a graphing calculator to estimate the x coordinates at which the maxima and the minima of each function occur. All right, so now we're going to go to a fresh function. Before I do anything, I'm going to press Doc B to clear everything because I want it to reset as well. So let's go to 2x to the power of 3 plus x squared minus 4x minus 2. Enter. That's what that looks like. And I hate this function here. I always move it away. All right. So I'm going to do one with you and you're going to do one alone. Okay. We're going to go to menu, analyze graph, maximum. I'm going to start at the one to the left. Maximum, bring it to the left, click here. Okay. So what do I write down? Right, x equals negative 1. But I'm going to say there is a relative maximum at x equals negative 1. Ella. Okay, menu, analyze graph, minimum. Whoops. Wait, what just happened here?
Yeah, that happened to mine too.
Let me see. Let me go to Windows Zoom. Let me go back to the standard Zoom. Okay, let me do it again. Menu, analyze graph, minimum. Okay, I wonder if it's because I clicked accidentally on the y-axis, and then when I dragged it, I don't know.
I'm gonna plug it in again.
Oh, okay. So we say relative minimum at x equals 0.667. Okay?
Well, it says to round to the nearest.
Oh, 100th. Thank you. So negative 0.67. Positive 0.67. Okay, with that, go ahead and do the next one, please.
normally here.
Mm-hmm.
Every time I try to plug in the last digit, it's just like
Okay,
it just does like the plus.
let me come over there.